Okay. Hello everyone, I am Furkan Taner, and this study is called Idiacoustic Investigation of an Uncontrolled and a Controlled Backward-Facing Step with Large Shadow Simulation. This is my outline, but I'm not going to each of them. I'm not going through each of them in the next slides. First of all, what is backward-facing step? In fact, this geometry is called backward-facing step. I'm not going to go through it saying backward-facing step. Rather than that, I'm going to say just BFC. BFC is available in many engineering applications such as aerospace applications, aircraft landing system. You can see in the right corner on the page. Industrial applications, I mean winds movements around high-rise buildings, automotive equipments, so on and forth. In simplified geometry is shown in the left of the page. Physics of the BFC flow. When you look to the BFC flow, you're going to see that flow separation, BFC flow field is divided into 4 regions. First, separated shear layer in here, I'm showing with my cursor, and primary recirculation region. I'm going to continue like that. Primary and secondary recirculation region under shear layer and reattachment region. Flow separation from the step edge leads high speed eddies, large energy losses, vibration and noises. This is my computational domain. I'm going to talk about a little bit about that. We have a step in here, and step height is equal 0.025 meter, and length of the upstream is equal 16 hash. Length of the downstream is equal 56 hash, and cross section. We have a rectangular cross section. Rectangular cross section width is equal 4 hash, and height is equal 10 hash, and we are giving velocity from this inlet. And velocity is equal 5 meter divided seconds. And we have a low Reynolds and low Mach number, which is shown in the takeaway box. Our Reynolds numbers equal is 0.0855 times 10 over minus 5, 10 over 5, or my number is equal 0.050. And this is the closer look to the step. As I mentioned previous slide, we have a step, and step height is equal 0.025 meter, and we have a slot in here, and slot size height is equal 0.95 times 10 over minus 3. We are putting a slot in here for one specific reason, because we are going to give suction and blowing velocities. These are the additional velocities, and I'm going to talk about really briefly about the aeroacoustic approach. Our aeroacoustic approach is Fox-William Hawking, and it is embedded in the ANSYS Fluent commercial tool, and here is its mathematical equation. When we come to the numerical results, boundary conditions are obtained firstly. Reference flow enters from at the inlet of the geometry. So inlet is given a constant velocity inlet, and we have an outflow which flow exits from here, and outflow has a 0 gradient, and the rest of the area is defined as walls, such as top and bottom wall. After obtained boundary conditions, grid independency works are done to investigate the defined optimum max size and computational cost. So 5 different cases are set up and compared each other. After the compression, mesh 4 is chosen for further calculation. Mesh mean we are meshing this structure to analyze it. And mesh 4 was equal 3.3 million, and it gave us the best computational results. If we solved our turbulence model with using large-scale simulation, under large-scale simulation, it can be observed we have subgrade scale model, and among of them, kinetic energy transport are chosen for a best nominee. When we talk about results and discussion, we have 4 different stations, and the stations are extracted from, namely x divided h equal to 4, 6, and 8, and h was equal 0.025 meter. I just wanted to remind that. The velocity, all stations give significantly good results when it's compared with experimental study, and it's shown in this graphic. This is the numerical and experimental comparison of the station results, velocity station results. After obtaining a great agreement between the station results, mean pressure coefficient, I mean CP, is obtained and compared with numerical and experimental. And it's also clearly observed that there is a good agreement between experimental and numerical study. In addition to that, I just wanted to give a brief explanation about the reattachment point. Reattachment point shows itself where the pressure signs change. It means that pressure signs starts minus and it turns positive in here. It's approximately equal x divided h4. I just wanted to justify to the reattachment point, so I put this contour. This contour shows that reattachment point, again, I'm going to say that where the sign of the pressure volleys change, and it's clearly seen that sign of the pressure is changed where when the x equal 0.11. So it shows that the graphic and the contour match each other. After that, we didn't have any suction or blowing velocities. We just had a reference velocity, and all comparisons were done for these reference velocities. After that, we gave suction and blowing velocities from the slot. And these are, and it can be seen that additional flow velocity, I mean suction and blowing, 2 suction, which are G1 and G3, and 2 blowing, which are G2 and G4. Odd numbers resembles suction, even numbers resembles blowing velocities. Here is the another comparison of the velocity profiles for suction cases. It's compared with experimental and numerical study, and it's all we can easily an acceptable agreement can also be seen between experimental and numerical studies in here. In the literature, blowing cases have not been applied for this geometry after observing good agreement between suction and no suction and blowing. Blowing velocities are given from the slot, and here's the plot of blowing case station results. When we come to the acoustic results, totally 35 receivers have been set up onto BFC's different location. However, we're going to discuss just 3 microphones, 3 receivers. These are receiver 9, receiver 20, and receiver 35. Firstly, receiver 9 is shown it here, and it is decibel results of the receiver 9 for suction, blowing, and no suction blowing cases are showed in here. As you can see in here, G3 is a suction case, and it has the highest SPL result, which is approximately equal 75 decibel. And G0, which is no suction and no blowing cases, only reference velocity given case, has the lowest SPL, which is 40 decibel. When we look to the receiver 20, we can easily see the same corresponding response in terms of SPL. Suction cases which is G3, has the highest SPL, which is approximately 80 decibel, and no suction and no blowing has the lowest SPL, which is 60 decibel. When we look to the receiver 35, it is also seen that G3, which is a suction, has the highest SPL, G0 has the lowest SPL. When we come to the conclusion, it can be said that receiver 20 is the nearest microphone. Receiver 20 is the nearest microphone to the retouchment point, retouchment region, so it's exposed to the highest sound pressure. Receiver 9 and receiver 35 are located at the same distance. Oops. Receiver 35 and receiver 9 located at the same distance to main source region, but receiver 9 shows higher values because it's nearer to a down relay region compared to receiver 35. Briefly, it's commonly expected that DFC structure should have reduced recirculation zones because you just don't want the chaotic environment, turbulence length. You just wanted to shorten the reattachment point because when you lengthen it, you will have a lot of turbulence, a lot of vortexes in the air. You just wanted to shorten that. When we look at G0, which doesn't have no suction and no blowing, only just the reference velocity, it has the longest reattachment length compared to others. But giving suction or blowing velocities from the slot creates reduced recirculation zone. However, this leads reverse situations in terms of acoustic results. When we look at the acoustic results, G0 has the longest reattachment length, but lowest SPL. But when we look at the suction and blowing cases, we observed a shortened reattachment length, but highest SPL. Thank you for listening, everyone.
Evet.
Is there any question?
Thank you, Kamil.
Is there any question? Comments?
I think no.
It seems not. Thank you very much for your nice presentation.
Thank you.
Finally, you did it, and it was a very good presentation. Congratulations.
Thank you. Thank you. COVID affected all of us, so working remotely and presenting something remotely is really tough. And all of us didn't have some same and similar connections. So
No problem, no problem. Everything was okay at the end.
Mhm.
Let's continue with the next presentation.
of course.
With
Yes.
the next.
Yes, there is a Paul Python ready to present.
Okay.
Am I right?
Yes, yes.
Evet.
Okay. So we can go on.
Dinliyordum.
Yeah, we have to see the presentation on the screen. Can you hear us or not? Can you hear? Can you hear us?
Python Paul, can you hear us?
Yes, I can hear you. So I guess we have like 3 minutes to start the new session, right?
We can.
Professor Zhang, I think there is no speaker in your session.
No speaker in my session? Oh,
No.
okay. So how should we do? We just end the session and we could go for we will go for supper, right?
Yes, there was just one presentation. and he asked us to reschedule his work now during this section, the actual section. So I think you're free.
Okay. Thank you. Anyway, thank you.
Okay.
Okay, bye. So I will quit the room and maybe expect that tomorrow I can also help.
Okay. Okay.
Okay,
Thank
bye.
you. Good afternoon. Thank you.
Okay, bye.
Is there any chance to have Elise, or I think not?
Python Paul, if you're ready, we can hear your presentation. We cannot hear you, and we cannot see your screen.
Amerika'ya gitti. Ben dedi bir hocayla konuştum burada. Gel dedi. Şey yapma dedi. Uğraşma bunlarla dedi. Fakat o işe
Now
şanssız.
we can see Elise.
Okay.
We can see Elise.
Okay. Elise, if you want, you can present your work.
Kendirebiliyor.
Yeah. Can you hear me, Elise?
Python Paul, we can see you, but we cannot hear you. You have your microphone turned off. Please turn on.
Okay. You hear me now?
Okay, now we can hear you. You can go on with your presentation.
You see my you see my presentation?
No.
But I can I don't know if I can present without showing the the screen. It is possible?
Maybe we have connection problem. We can go on without any slide if you want.
Okay. Okay. Oh, thank you for have given me the opportunity to present my work. And third, couple an agent-based model with a mathematical model of Rift Valley fever for studying the impact of animal migration of Rift Valley fever transmission. The plan is introduction, mathematical model of Rift Valley fever, agent-based model of animal migration, coupling of the agent-based model with a mathematical model, numerical simulation and result and conclusion. An introduction, Rift Valley fever is a disease killing principally animals. During contacts between animals and mosquitoes, animals can be infected by mosquitoes. Migration of animals increase the risk of new infection. Mathematical models have some limits. Parameters values are often constant. It is not always true in the reality. Agents-based model can help mathematical model to take into account the stochastic approach of parameters values. The objective of this work is to couple an agent-based model with a mathematical model in order to take into account the stochastic modeling. For our mathematical model, we have interaction between host population animal, Aedes vexans mosquitoes population, colleagues mosquitoes population. In the first system equation, we have interaction between Aedes mosquito population and animal host. The second system equation describes the interaction between colleagues mosquitoes population and an animal host population. The third system equation describe the interaction between animal with host, with Aedes mosquitoes population and Culeus mosquito population at the same times. The description of agent-based model. For migration, we have identified two species of agents, the truck agents and the city agents. Each city agent, called city agent, use the mathematical model to compute the number of infected animals at each step of simulation. A truck agent allows the transportation of animal hosts from one city to another city. The couple model, here we have the screenshot showing relationship between animal and agent-based model describing Rift Valley fever. The mathematical model is a method of city agent. The truck agent can move from city agent to city agent. For our simulation, we built 5 city agents, and here we have the screenshot showing the 5 virtual sitting agents and the first line of the source code of the mathematical model managed by the city agent. For CT1, we have 5,000 eggs of Aedes vexillans mosquitoes, 1 infected Aedes vexillans mosquitoes, 5 infected animals, 1,000 susceptible hosts. In the other city, we have 5,000 eggs, 0 infected Aedes vexillans mosquito, 0 infected animal, and several simulations were carried out corresponding to 200 days. After our simulation, we present the dynamic of infected hosts in all cities without migration. We see that the number of infected hosts is equal to the number of infected hosts within city number 1. In all cities, we have the dynamics of infected animal with migration in all cities. We see that when there exists the migration between cities, there are an increase of the number of infected animal. We also see the impact of the migration of animal in the city 1, and we see that there also exists the increase of the number of infected animal in the city number 1. In the city number 2, we also see the increase of the number of infected animal. At the beginning of the simulation, the number of infected animal is 0 in the city number 2. In conclusion, we can say that in this study, we have built an epidemiological model of the Rift Valley fever transmission, taking into account migration between cities. The two couple models confirm the fact that migration of infected animals increased the total number of infected cases. The couple model allows resolving some limits posed by the two models, the mathematical model and agent-based model. With the couple model, it is possible to know the average number of infected animal hosts in all cities at every time. We have shown that when certain cities are in quarantine, it is possible for observing the evolution of the Rift Valley fever transmission in the other city. Thank you. It's all. Hello? It's all.
Thank you. Thank
Okay.
you very much. I think
Okay.
we keep having problem with the connection by the chairman. It was very interesting, and
I am
I'm
here.
very sorry we cannot see your presentation.
I am
Okay.
here.
Okay.
I listened to the presentation. Very good. Congratulations for your paper. We can
Okay.
imagine the formula. But
Okay. I
very
tried to share. I clicked on the button to share my presentation,
there is
but
a connection
there is no problem of connection.
There is a connection problem. Thank you very much for your nice
Okay.
presentation. Thank you
Okay.
very much.
Okay. Okay. Thank you.
What can we do now?
Any news about Elise?
Let me call her. Just a moment. Yes, how are you?
I'm okay.
I am still chairman, still waiting for you.
You are the best,
Any?
really. It is continue?
Yes, yes. If you wish, you can present.
You are so.
No, no.
But it is not possible because I stand up and now it is not possible. I cannot
Ben
connect
çatıştırıyorum.
the internet connection. It was very bad. Now I moved other side and that's all. But I will again try to their internet connection. It is another. Which one? Cafe. This is Radan. Yes, yes. Another cafe. I'm there. So I will attend. I think that. But how was the conference?
One presentation only after you left. Furkan.
I cannot.
For Furkan. And two presentations, actually two presentations, one after Furkan.
Where is the dog?
No, I cannot see him.
Really? Run away.
Yes, yes. Try to call, if you wish, you can present.
I will try. Okay?
Okay, bye-bye.
Okay, bye-bye.
She is trying to connect, but there is a connection problem.
Okay. So we missed just one speaker, the last one of the session AC2. Am I right?
Yeah.
Elise should present 3 works, right?
Yes.
Okay.
I cannot present because she didn't upload or you didn't. So otherwise, I can present it.
Okay, we can wait.
Yeah.
Angela, I was in contact with the chairman of the next session, and he should come, but
yes, but there is no speaker.
okay.
I explained to him because the only work should have presented in the last session was rescheduled because we had a problem. Oh, okay. We had problem of connection.
Okay. Thank you.
Thank you. Thank you. Is there any possibility to reach Elise?
I talked to her by phone.
Okay.
She told me that she's trying to do. Yeah.
Okay.
Still listen. Still we are here.
Okay. Maybe we have our speaker.
Yes, we have.
Oh my
I think
God.
that Furkan.
Okay.
There is the Furkan. There is Furkan.
We missed
Yes.
you so much.
Yeah, because I am outside and I don't have a connection. I moved another cafeteria, so I'm so sorry for this situation. I am calling Furkan.
Furkan is okay. Come present it.
Öyle mi? Really? Where is Furkan?
Yes, yes.
Can I ask question, Furkan? Furkan?
When you want, you can start. When you want, you can start with your presentation.
No, I am talking about Furkan. Where is the Furkan? Furkan, complete Furkan's presentation completed?
Yes, yes.
Yeah.
Okay, but now I uploaded presentation and this is the another computer, so you can check one presentation you have. I think that
Maybe you can share the screen.
Yes.
but this is another computer, so I don't have a presentation. I uploaded. I don't have this presentation now.
Sorry, I can't see them. You uploaded,
I uploaded
them.
only one presentation, and I don't know. So that.
But you have uploaded them on Riot platform?
Yes.
In the room AC 2020?
Yes.
Because I cannot see them. I am in the room and I can see just one presentation.
No.
I don't know.
Also, when I see it, I see three presentation, other three presentation. But no, this is not cheap. This room. Whatever. Now I don't have this presentation in computer, so we can pass.
You have just one of them, right? Or maybe you can discuss them without any slide. I don't know. As you prefer.
If you can see the presentation.
No, I don't have this presentation in this. No, I cannot see it because this is not. It is not this room. Real. I think it's matrix. That's all. I don't know. Whatever. I am not. I cannot see it. So. I think that that brings us to end the end of the this section. So I'm so sorry. Okay. If you have other participants, you can continue because I cannot find it. It is not possible now. If you cannot find one presentation, I upload it.